Okay, so today we're going to talk about slope, and we're going to talk about what is slope, and we're going to talk about starting to find how to find slope from a graph. So a few examples of what is slope, okay, and where slope happens in the real world. Slope occurs like when you think about the roof of your house, okay. It means like how steep it is. Okay, so they measure your roof of your house by finding the slope. All right, part of my dog, she's wanting to play right now. Um, But that's where the slope also comes in, is when they do the roof house. So like I worked at Menards, I had when I was selling people roofs and stuff, and we were building houses. You always had to figure out how steep they wanted the roof, so we had to figure out their slope. Okay, and one of the common ones is 412, which means 4 up over 12. I mean, it's just 4 feet up over 12 feet. That was the common slope. Now there's a lot of different ones, but if you ever want, you're curious, ask your parents see if they even know the slope of their roof. Another example is if you go skiing. Okay, how steep is a mountain? They have different grades. You're obviously if you're just a beginner on skiing, you're not going to go down the steepest slope or the steepest mountain. Okay, that means the slope is high. You have a great slope. Now you're going to want a slope that is not as steep. That's pretty flat, just to get your bearings. So that would have a small slope. Okay, or a lower slope. Okay, so that's another example of where slope comes in. Another one is that I like to think about now this is after I worked my summer job a couple years ago, is like handicap ramps. Okay, when you walk up there, you'll notice they slowly incline up, and then this one, it inclines in both directions. That has a slope. It has a steepness, and when we actually made these, we had to make sure that we were in a certain we were in a certain percentage or whatever. We had a certain mark we had to reach, so that way they were in compliance with these requirements that the government has set. So that's another example where slope is used. Okay, there's a ton more examples out there where slope is used, but these are just a few of the three that are known. Now, like I said, though, we're going to be talking about what is slope. So, getting into what is slope. So, this is the thing you're going to have to remember. Slope is going to be the following. Okay, it's going to be remembered as the change in y over your change in x. So, how much you change. So when you think of change in y, how much you change up and down over how much you change side to side, which some people like to remember as the rise. How much do you rise over how much do you run? Okay. And in this class, you're gonna hear me say, I'm gonna write it like this a lot. Delta x or delta y over delta x. That is the same thing as change in y over change in x. The triangle in this case means change in, all right? But that's what slope is. We're going to figure out how much do we change in our up and down or y values over, which is going to be a fraction, we might have fractions here, over how much do we change in our x values, which will be your side to side, okay? So we're going to look at a few examples here now, okay? And this is how you're going to find slope from a graph. So looking at this first example, when you look at a graph, the first thing you're going to have to do is locate 2 points. So I'm just going to locate 2 points that I know are exact points. Okay. And I also notice that this graph does not go by ones all the time. So I'm going to pick a couple different ones. I see this one, and I'm going to pick this one up here. It doesn't matter where we pick our points, as long as you got 2 points. Okay. So when I do this one here, what I'm going to do is I'm going to make this thing called a triangle. And we call this the slope triangle. Sorry, my dog's not having a nice night. So we make a slope triangle. You always see me, I generally make my triangles on the bottom. It doesn't matter if you make them on the bottom or the top. No matter what, you should get the same answer. What I'm going to do is I'm going to make my triangle. Okay. So I'm going to go over. I'm just going to connect these. And I'm going to choose 2 different colors here just to help out. Now, when we do this, we got to remember our slope is, I should tell us, our slope is represented with the variable m. So if we say m, we are meaning slope. I should go back up there and write that in there. Okay. Slope is represented with m. That's the variable that we use. Okay. So when we find our slope, I'm going to go and reference it. We're going to say change in y over change in x. I'm going to put this, and I did this in colors for a reason. Change in y over change in x. So remember, y is up and down, x is side to side. Okay. So what I'm going to do here is I'm going to go ahead and count my numbers. I'm going to work left to right through my triangle. Okay, so I'm going to start with the bottom part because that's this one in red. I'm going to count how many I go over. Now, you'll notice here each box is not by 1 in this case. Each box is by 0.5. So over 0.5 over 1, so that's 1. So I'm going to put a plus 1. So my change in x, and I'll go ahead and say this, my change in x is 1. And it's a positive one. It's important that you keep track of which direction you're going. I'm increasing here. I'm going from 0 to 1. So that's how I get the positive 1, because I'm getting bigger. So there's my change in x. Now let's look at the change in y. Okay, this time going up, though, on this box is by 1s. So I'm going to count up. So I go 1, 2. There's 1. Because I start there, that's 0, 1, 2, 3, 4. Okay, and now since I was going up this time, going up on a graph is positive. So I'm going to say plus 4. And that is my change in y. So now what I'm going to do is I'm going to go back to my equation over here on the left-hand side. I'm going to write my slope. My slope is change in y, which is 4. Okay, and it's a positive. You could write the plus if you want, if you don't need to, over my change in x, which is 1. And it's a positive 1. So now you've got your slope set up as a fraction. A slope is going to be represented by a fraction a lot, but we're always going to want to reduce this. So I'm going to go ahead and reduce this here. 4 divided by 1, which is just 4. So my slope in this case for this problem is 4. So m equals 4. That is my slope. Okay. So that's the slope of this graph. That's how steep this graph is. It's a 4. Okay. All right. Now let's go to the next one. Oh, I should say this before I go on the next one. Now, you should ask yourself, is this graph increasing or decreasing? Okay. So from left to right. So as you look at a graph, I'm going to draw an arrow. From left to right, is the graph getting bigger or smaller? So is it going up or is it going down? In this case, it is going up. So this graph is increasing. Okay. So whenever you have an increasing graph, your slope is going to finish as a positive number. That's one thing you can do to check, is if it's increasing, your slope should be a positive. And we have a positive 4, so we're good to go. All right, so let's take a look at another one here. Let's take a look down at this one right here. Okay, so we're going to do the same thing. We're going to find the slope. So we're going to find the m value. So slope, which is rise over run, if you want to think of it as that. So how much do you rise over how much do you run? Okay, we're going to do the same thing. I'm going to do my change in y over my change in x. Okay, and that's what we're going to find here. So I'm going to go ahead and pick 2 points anywhere on the graph. The 2 points don't matter what you pick. Okay, now they got to be even points. You want to pick good points. So I'm going to go ahead and pick 2 good points here. I'll do these in purple. Here is a point I see right there. Okay, and then here is one that I see right there. So I picked those 2 points. Now I'm going to go ahead and make my triangle. And like I said, I like to make my triangle on the bottom and so forth. So I chose change in y as blue. Remember, change in y is up and down. So I'm going to go ahead and make my up and down part of my triangle in blue. Okay, and then I got my change in x, which is side to side. So I'm going to go ahead and make my triangle between those 2 points in red. All right. So let's go back now. So like I said, I like to work left to right. So working left to right through a triangle, going from this first point and the far left all the way to the second point. So I'm going to follow my triangle. You'll see this time it goes down. So my change in y in this case, since I'm going down, you think on a graph we're going down, that means we're getting negative. So just count down then. And these are by 1s here. When I count down, so I go down 1, down 2. So this change in y in this case is a negative 2. All right. So I got my change in y there. Now we're going to go do our change in x, okay, which is side to side. And I'm going to count over. Now we're going right here. Since I'm going to the right, okay, it's going to be positive on the graph, even because our numbers are getting bigger, which is okay. It's positive. So I'm going to count over. So I go 1, 2, 3, 4, 5, and 6. So that is a plus 6. It's a positive 6. Okay. So now we're going to take this back to our equation, okay, for our slope, or what is slope. So my slope, which is my m, my change in y here we had was a negative 2 over my change in x, okay, my change in x, which is a positive 6. I could write a positive 6. I'll just put my plus sign. I got a positive 6. Now, we've got our numbers filled in, but we always need to check, can we reduce? So a negative divided by a positive is going to be a negative. So I'm just going to leave the top one as a negative here. It doesn't matter. I always just like to put it at the top. Okay, but 2 over 6, what can each of those numbers be divided by? Well, you should hopefully be like, well, 2 and 6 can both be divided by 2, Mr. Graber. Okay, so 2 divided by 2 on the top, I'll go ahead and put 2 divided by 2 is a 1. So I'm going to have a negative 1 on the top, over 6 divided by 2 is a 3. So our slope is going to finish as I have there, negative 1 over 3. And there is the slope. Now, one thing we should do here is check our answer to make sure we at least have a positive or negative correct. So ask yourself, from left to right on the graph, is it increasing or decreasing? Okay. In this case, it is decreasing because we are getting smaller. The graph is going down towards the right. Okay, so this is a decreasing graph. So when we have a decreasing graph, we should have a negative slope. Okay, we should have a negative slope. All right. I'm going to go and scroll up here to this one. Oops. Scroll up. So here's another problem. All right. This time, I want you to pause the video here in a second. I want you to try this problem. Okay? But I'll go ahead and write up here for you what slope is. Remember, slope is change in y over change in x. Okay? So I want you to think about this problem. I want you to kind of use your finger, track it, and stuff like that. All right? I want you to see if you can come up with an answer and then resume the video here in a second, or once you complete it, to see if you got the correct same answer as me. All right, so picking up here, I'm going to go ahead and pick 2 points on here. I'm going to pick 2 good points that I like. I'll put them in purple again. I like this point, and I'm going to pick this one here. I like that one too. Doesn't matter which one. You can have a different triangle. You can make a smaller triangle if you want. Some people may like, Mr. Gerber, that point right there works. Okay, cool. I don't care. No matter what, you should get the same answer as me, okay? So I'm going to make my triangle again. I'm going to do my change in x in red again. I'm going to do my change in y in blue. I'm going to connect those 2 points. I'm going to make those go, okay? So remember, my change in y is blue. My change in x is my red. All right, so I'm going to go and count. Remember, I do left to right, and I build mine on the bottom. Doesn't matter if you build them on the top. You should get the same answers, though. So my change in x from left to right, since I'm going from left to right, is positive. Okay, so I got 1, 2, 3, 4. So that's a positive 4. So I'm going to put a plus 4 there. Okay, then I'm going to go to my change in y, which is the blue. And this time I'm going up to finish my triangle. From here, I'm going up. Okay, so I'm going to count up. So I go 1, 2. So my change in y is a positive 2. So now what we need to do is we need to go to our equation. We need to write this in. So my change in y, my top part, is a positive 2. So I'm going to put that up there. I'll put the positive sign in there. And I'm going to have it divided by my change in x, which I had was a positive 4. So I have a plus 4. All right. Now, a positive divided by a positive is positive. So I don't even need those positive signs anymore. And 2/4. Think about what 2/4 reduced to. We should be like, oh, both those divide by 2. Okay. And 2 divided by 2 is 1. And 4 divided by 2 is 2. So my slope is 1/2 for this graph. My slope is 1/2. Okay. Now, remember, you should do one thing at the end. Check from left to right. Is your graph increasing or decreasing? Well, our graph is getting bigger. It's going up. So remember, since it's increasing, we should have a positive slope. Okay, it's getting bigger. Positive means it's getting bigger. Negative means it's getting smaller. Okay, in this case, we're getting positive. It's getting bigger, so I'm going to have a positive slope. No, excuse me. All right, let's see here. I know I have another one in here somewhere. All right, I'm going to have you try one more here now. Okay, so this one right here. I want you to do the same thing. Pause the video here and pause the video and go ahead and try this problem. All right, so picking up here. Remember, slope, m, is going to be equal to change in y over change in x, okay? We're looking at the change in y over change in x. So that rise, which is our y, how much up and down, over our change in x, which is our side to side. Okay, so I'm going to go in and do the same thing. I'm going to make my 2 points on here. I see this point, and I see this one right here. Okay, so I'm going to go ahead and make my triangle. I'm going to draw my triangle connecting these 2 points. Now, this one I made a smaller triangle, which is all right. Okay, remember your change in y is on the side. So count. Now, this time, working left to right, my change in y, I'm counting down to make my triangle. So I'm counting down 1, down 2, down 3. Counting down means we're going negative. So I'm going to have a negative 3 for my change in y. Okay, and then my change in x. I'm going to count over to the right. Going right on the graph means positive. So I'm going to have a positive 1. Okay, so that's my change in y. Or my change in x, sorry. So now I'm going to go ahead and fill these in. So my slope. I said my slope for my change in y is a negative 3. And then I'm going to have over my change in x, which is a positive 1. So now think about it. Can you reduce negative 3 over positive 1? So negative 3 also divided by positive 1. Okay, what does that reduce to? Well, negative 3 divided by a positive 1 is a negative 3. So my slope is a negative 3. Now remember, check one more thing at the end. From left to right, okay, on the graph, is it increasing or decreasing? Well, if you track that from left to right, it is going down. It's decreasing. Okay, so since it's decreasing, we should have a negative slope. So we got to double check, do you have a negative slope? And yes, we do. So we're good to go. If you have the opposite, you know you made a mistake. So that's something you can fix pretty easily by just checking if it's increasing or decreasing. Okay. All right. So we're going to go ahead and resume that in class. But please make sure please make sure you ask if you have any questions. And have a great rest of your day.